Welcome to the course series ChatGPT and other awesome AI tools. We were looking at applications of ChatGPT in data science. In earlier lectures, we have seen how ChatGPT is useful for various stages of data science life cycle. We had already done problem identification, business understanding, ETL, and exploratory data analysis or EDA. And we saw that the code which was generated by ChatGPT worked like a charm for this exploratory data analysis. In that, some feature engineering was also involved. For example, those who do not remember can just refer that lecture. There, we calculated employees' total salary by adding uh, uh, DA and basic. That I think we did when we did this use of ChatGPT for creating an ETL pipeline. But in short, feature engineering means combining two features, say DA and basic salary. These are two features to make a single feature so that the number of features reduces and that makes the model simpler. Simple is always better. Now we want to discuss about this thing, that is model creation. Now, what is this that we want to understand? For that, we want to take the example of linear regression. Basically, the various algorithms are often classified into supervised algorithm or unsupervised algorithm. There is another variety called semi-supervised algorithm also. But another way of classifying is regression or classification. So in most data science or machine learning models, what do? They either do regression or they do classification. Now, what is the meaning of word regression? Regression means predicting the value of some continuous variable. While what is the meaning of classification? First, in regression, let us take this example. Say, for example, I have a data set with 10,000 observations, and it is a very simple housing data set, in which there are only two features. One feature is the area in square meter, and another feature is the number of bedrooms in the house. And there is one independent variable or target variable. So these two are called predictors or features, while this is called the variable which we are trying to predict or target variable. That is the price of the house. So we are assuming that the price of the house depends upon this feature area x1 and this feature number of bedrooms x2, and this 10,000 observations data set we have, in which first observation has this area, these bedrooms, and this much is the price. I have also written in million. This is actually 1 crore in Indian currency language. This is 1 crore 50 lakh or 15 million. Okay, so these are the price. So first thing is, let us understand what is this linear regression. In linear regression, we take as a hypothesis, and I have underlined that word. Okay, so initially it is just a hypothesis only that price y, this parameter, varies with x1 area and x2, that is the number of bedrooms, in a linear manner. Now, even this word linear manner also will require some explanation, but that means if I want to make an equation, then y is equal to some constant beta 0 plus some other constant multiplied by area plus some other constant multiplied by number of bedrooms. So this is the meaning of word linearly varying. And remember, it is just a hypothesis that we assume that y, price, varies according to some such general equation with x1, that is area, and x2, that is the number of bedrooms. Okay. Now, if it would be just one variable, suppose even this number of bedrooms is not there, we take a very simple data set that price varies on area. Okay, so then it would be a very simple equation, y equal to beta 0 plus beta 1 into x1. This term beta 2 x2 won't be there because there is no x2 here. Okay, as I said, I take the even simple case. So what is linear regression? I put these various price on y-axis as data points. So these are those points by red colors. And I try to find a line whose various points are as close as possible to the red. This blue line is my uh, line of fit. And I try to find such a line of fit that its distance from these various points is minimum, because these are my predicted values. Blue values are all my predicted values. I am assuming that the price varies linearly with x. X is this, suppose only one variable, simple case we are taking. So then in that case, if it is varying perfectly linearly, 100% linearly, then all my predicted values would come on this blue line. Okay, but actual data distribution is shown by these red colored dots. So it is not perfectly linearly varying, but there is some error in each observation between the predicted value, which is the red dot, and sorry, blue point, and the actual value, that is the red dot. Here this is the actual value, and predicted value will always be on the line of fit. Again, this is actual value, and predicted value will also again always be on the line of fit. Actual, predicted. So you can see these red colored line segments, they show the difference between actual and predicted value. So our model or no model will be 100% perfect. That is, no model will pass through all the data points of the actual data distribution, that is all the red colored data points. Okay, but we should try to find some acceptable line of fit, so that at least the sum of square of these errors, each red segment, that is the error term. Okay, difference between predicted value blue on the line and actual value, that is this red. So this line segment is the error. Then so sum of squares of all these errors, that should be minimum. Okay. Then, or in other word, accuracy is not 100%, but it should be maximum. Now when we take two variables, here I had taken, remember I said that initially forget about even bedroom and assume that y varies, price varies on only area. So then you would get this kind of line and this kind of line of fit, and this would be data point. But here our price depends on two variables, x1, which is the area, and x2, which is the number of bedrooms. As a result, these are the data points again, red color, all various data points. So here we don't try to find a line, but we try to find a plane of best fit. Okay. So this is actually not equation of line. This y is equal to beta 0 plus beta 1 into x1 plus beta 2 x2. That is the equation of this plane. This is called a hyperplane. And again, We cannot find a plane so that it 100% passes through all red colored points, which are actual data points. These are the actual values of price. But we should try to find one such plane so that some error remains, but the sum of square of error is minimum. I hope you are getting what we are trying to do. Okay, fine. Now, if beta 0, beta 1 and beta 2 can be somehow found, these and these, then easily price can be predicted, because suppose this kind of equation, beta 0 is 0.21, beta 1 is 0.33 and beta 2 is 0.11, and suppose I am given some 10,001th observation where the area is 300 and the number of bedrooms is 5, then I just have to plug in this equation 0.21 into 0.33 multiplied by 300 plus 0.11 multiplied by 5. That would give me the price, say in million directly, suppose. So that is how you can find the price. So the question is how to find this beta 0, beta 1 and beta 2. Here the approach of mathematics and the approach of machine learning differs from each other. In mathematics, we try to solve some actual complicated equations, simultaneous equations, and try to find the value of these unknowns, beta 0, beta 1, and beta 2. Because as I said, once they are found, you just have to go on plugging any area and any number of bedrooms, and you can easily predict or actually calculate the price of that uh, house which has that much area and that many number of bedrooms. However, in the machine learning, we don't do this. We find do not find beta 0, beta 1 and beta 2 mathematically, but there we take a different approach. And what is that different approach? Here I have kept those two figures just for reference. In machine learning, we divide the data, that was our data, 10,000 observations. So we divide that data into, say, train set of first 8,000 rows and test set of 2,000 rows. Then we select some linear regression algorithm. Okay. So again, we are assuming just that our data points are so distributed so that they are linearly separable. In two dimension, they are linearly separable by a line of fit. And in three dimension, like our case where price of house depends upon bedrooms and the area of the plot in square meter, then in that case, this is the plane of fit. Okay, so we select linear algorithm, regression algorithm, and we train a model using that algorithm on this train set, that is first 8,000 rows. At this time, we use x1, x2, y, all columns. So that means we use the predictor variables as well as the target variables. Then we test how accurate the model is for the unseen data. That is for this test set 2000 rows. Unseen here means while training, the algorithm was not exposed to this data part. It was trained only on the top 8,000, so it had not seen the result. What are the values of y? Okay, so data which is not used for training, that test data is called unseen data, and we test how accurate. So how we test it? We this time we only find take x1 and x2 as known, use our model which we have obtained by training it on these 8,000 rows, and we predict y, okay, using the model. And then we already have the actual values of y for all 10,000 observation. So we compare the prediction and the actual value. As I said here, these red colored dots are the actual values, and this blue, anything on this plane, they are the predicted values. So when we compare means we find the difference between them. That is called error term. And for certain reasons, we don't consider error, but we consider squares of error, and for first point the square of error, for second point square of error, third point square of error, all that, and we do the sum of that, and we try to minimize the error. So that means we try to choose that model which has minimum error or maximum accuracy. But every model will have some error. There is no such thing as 100% perfect model. So this equation of y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 is actually written this way, that y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus epsilon, where that epsilon is the error term. Okay, but error should be within acceptable limits. Say if your algorithm is around 95% accurate, then it is considered good. That also depends upon use case to use case. For example, if you are making life critical medicine, then 95% accuracy is not enough. But if you are predicting housing price, then 95% accuracy is far good. Okay, so that is how it is. Now, if the model has sufficient accuracy, suppose my model comes out to be having 96% accuracy, then we use it to predict house price of any unknown but similar data distribution. So that means that these are 10,000 rows, but now I am given some other data set which has similar data distribution. That is, there are certain assumptions in linear regression, and this data set should obey those assumptions. Similarly, that other data set also, similar data set which I am talking about, that also should be like this in distribution. So that means it also obeys the assumptions of linear regression. Then I can just use this model to predict, or rather find, the value of y. Of course, that prediction would be with around 95% or 96% accuracy, depending upon how good model we are able to make. Okay, so that is what is regression. So in very common language, regression means predicting the value of some continuous variable based on value of 1, 2, 3, or even more predictor variables or features. But as you go on adding more and more features, the model will become complicated, that you can understand, because more than 3 dimensions we cannot even draw and imagine. That is the limitation of human senses. But there are data sets where this y depends on, say, area, then number of bedrooms, then it depends upon the location, then it depends upon the, that is suppose the pin code, then it depends upon the whether or not number of parkings in the how many cars parking is available with that house. So house price can depend upon several factors, but then drawing such a diagram would not be helpful. But even in those cases, this statistical method which we have seen, that always work. What is the statistical method? I am very briefly repeating that: divide your 10,000 rows into train set of 8,000 rows and test set of 2,000 rows. Select linear regression algorithm and train that algorithm on 8,000 rows. At that time, for training, use features as well as the values of the housing price or predictor, target variable. Okay, then take the other 2000 rows, that is test set. That time you don't take the value which are in the table for the target variable. Instead, let your model predict what should be the value of target variable. But even for those 2000 rows also, we already know the actual values, so we can then compare how far off your model's predictions are from actual values. Here, these red dots are actual values, while model predictions are will be always on this plane because we are assuming linear relationship. Or in two dimension, model predictions will be on this line. Okay, but the actual data distribution would be different, and therefore there would be some error. So if that error is acceptable, say around 3 to 4%, or depending upon the use case, acceptable, then we say that yes, my model has sufficient accuracy, and then we try to use that model to predict on any similar data which is not even among this 10,000. So that is some, say 10,001th observation is given. At that time, some area is given, some number of bedrooms are given, and you are asked price, predict the price. If you have adequately satisfied yourself that your regression model has good accuracy, then you can rely on it for prediction. Okay. Thank you. So this is what is regression. Now we want to use ChatGPT for such regression task.